Dear students, welcome to Statistics and Dynamics with me, Dr. Loay Al-Zube, and we are continuing our discussion of Lecture 6, in which we are talking about the dot product. So we have presented in the previous video what are the challenges that we are facing that the dot product can help us with. And there we have two challenges. The first one is finding the angle between two vectors in three-dimensional space, and the second challenge is to find the projection of a vector along a particular direction. So we stopped after laying out the challenges, and now let's talk about the definition. So what is the dot product? So the dot product of two vectors A and B, let's say we have a vector A and B as you see in the schematic, and we have an angle between them, which is theta. And so the dot product defined is A dot B. And please note that anything that's bold and LaTeX and with red, that's a vector, right? So the vector A dot, this is the symbol of the dot product of vector B, is equal to the magnitude of A multiplied by the magnitude of B multiplied by the cosine of the angle between the two vectors. Please note these are two magnitudes, they're not vectors. And if you recall from previous lectures, the magnitude is the square root of the x component square plus the y component square plus the z component square in 3 dimensions, and that is the magnitude of any vector. So the angle is the smallest angle between the two vectors, and it's always between 0 and 180. So we need to establish that. So what are the characteristics of the dot product? So the result of the dot product is always a scalar. It's not a vector. And you can see that we have dot product A vector, dot product B vector. We have this scalar to the right. So A is a scalar, B is a scalar, and cosine theta is a scalar. So the end result is a scalar, positive or negative, and the units of the dot product are the multiplication of the units of the vectors A and B. So because we have multiplication, right? So if you have A in, let's say, meters and B in meters, or A in feet and B in feet. So if it's meter, it should be meter square. If it's feet, it's feet square. So we keep those in mind. So this is the definition of the dot product. Now, what does that mean in Cartesian coordinates system? So to put things in perspective, let's look at these examples. You know that the I, J, and K are the unit vectors of the Cartesian coordinate system. So I is the unit vector of the x-axis, J is the unit vector of the y-axis, and Z is the unit K, sorry, and is the unit vector of the z-axis. Remember that the axes x, y, and z, they are orthogonal axes, which means that the angles between them is 90 degrees. Now, if we know that the angle is 90, cosine 90 is 0, right? So if you are doing a dot product between I and J, so this is the x-axis and this is the y-axis, the angle between them is 90, whatever values, this is 1 and 1 because it's a unit vector, multiplied by cosine 90, that's a 0. However, if you are doing a dot product between I and I on the x-axis, so that's 1, and the angle between the x-axis and the x-axis is 0 because they are projected along themselves, so along the same direction. So that's 1. So in summary, doing the dot product, it's the easiest thing to do is to multiply the x components with the x components. So if you have two vectors A and B, A is an AX, it has a AXI plus B, AXI plus AYJ plus AZK, and the same thing goes for B. So if you have a dot product, you just multiply the x with the x, so AX multiplied by BX plus AY multiplied by BY plus AZ multiplied by BZ, and you forget all about the IJK because the dot product result is a scalar. I hope that clarifies it. So how is the dot product useful? So we know this concept. We recognize it from probably previous courses in physics. So we want to use the dot product to determine the angle between two vectors. So how is that being done? We have 3 steps to do this. So first we will find so we have to write the vectors in Cartesian form, I, J, K. And the thing is that you need to do the dot product. So you multiplied, as we mentioned before, the AX with BX plus AY plus multiplied by by, and az would be z. So this is your right hand side. That's what's going to happen from using the Cartesian form. It's important. So that's step one. Step two, you need to find the magnitudes of a and b as vectors. And if you recall, the magnitude is the square root of the x component plus the square root of the y component. If we have 3 dimensions, plus the square root of the z component. So step one, do the dot product, which means multiply the Cartesian forms together, the x with the x and the y with the z and the z. Then for each one alone, a alone and b alone, you find the magnitudes. After you do that, you can find the theta and to solve for the angle. So how does that is that being done? Look at this formula here. You have a dot b. If you multiplied ax, bx, ay, by, az, bz, that's this left side. Refers this side of the equation. You know the magnitude of a and b from using the square roots of the x component square plus the y component square plus the z component square if it's 3 dimensions. Note that they are not bold, so those are scalars, and multiply by cosine theta. We have the Cartesian multiplication, we have the magnitude. I can do cosine inverse and find the theta. Cosine inverse, this multiplication divided by the two magnitudes. And this is how you calculate the angle between any two vectors in space. So I hope that clarifies the process and how can we use the dot product in finding the angles. We're going to do a lot of exercises and problems in the in-person session. So now we would like to move to the next step, which is the next challenge. How can we use the dot product to find the projections of vectors on a specific direction? So thank you for watching. Until the next video. Bye.